Howdy! This is your friendly neighborhood physics teacher here to do some practice problems on dimensional analysis. So I'm going to do the dimensional analysis homework, and I'll step through what I would do to solve the problem. So the first problem I'm going to do is the one that says we need to convert, let's make sure, we're going to convert 66,893 centimeters, and we're trying to get to miles. So we're going from centimeters to miles. Now, we do need to have our chicken duck handy so we can do that, because we need to figure out, can we go directly from centimeters to miles, or is there a way we need to do a step in between? I'll give you a hint. We need to do a step in between. So, now remember, we always put our given in the first little section. So our 66,893 centimeters goes there. There's no per, so 1 goes underneath there, because remember, per means divide. So we're not dividing by anything. We do not want centimeters. So where does centimeters need to go so it cancels? On the bottom. So we need 1 on top, 1 on bottom for it to cancel. Centimeters have to go in the bottom. But if we look in our chicken duck, there's not a conversion from centimeters to miles. But there is a conversion from centimeters to inches, because we need to get it from metric to that English system. So if we look in our chicken duck, we have for 1 centimeter, there's 0.3937 inches. And so our centimeters cancel. But we don't want inches, we want miles. So we look in our chicken duck again. There is a conversion from inches to miles. So we don't want inches, so inches have to go down here. And we want miles, so we put our 63,360 inches in 1 mile. Again, that causes our inches to cancel. So we are left with miles. You multiply across the top. So when you multiply across the top, you get 23,335.77 miles, because that's our. We multiply across the bottom. Well, 1 times something is just that something. So we're left with that. There's no unit on the bottom. So then we divide. When you divide, you get 0.0416 miles. So that's in standard form. So this is in standard form. But we want it in scientific notation form. So to put it in scientific notation, we want the decimal to be 1, where there's 1 number in front of it. So we have to move it back 1. Anytime you're going from a bigger number to a smaller number, what I mean by that, so 0.146 is smaller than 4.16. That's bigger. So anytime you're going from a bigger number to a smaller number, you're going to end up using a negative. It would be a negative. So our answer is 4.16 times 10 to the negative 1 miles. Now there is variations in this. You could have used the other conversion here. So there is a different conversion here. You could have done 1 inches per, I think it's like 2.2 centimeters or somewhere. It's something like that. I don't have that on me right now. And I don't think there's another conversion but there is a different way of doing this. But you should get around the same answer. So the next one I'm going to do is when we have to convert the 55 miles per hour into meters per second. Okay? Miles per hour, meters per second. So I'm going to do it a little bit different. This is a couple of students I've helped this has seemed to help them. So we're going to focus in on the miles first. So that is mile. So we're going to do 55 miles. We're not going to worry about the per hour right now. We're just going to focus in on the miles. So we're just going to put a 1 right there. So we don't want miles, we want meters. But if we look in our chicken duck, there's not a direct from miles to meter. But there is a miles to kilometer. There is a mile to kilometer. So for 1 kilometer, there's 0.621 miles. And that would cause our miles to cancel. But we didn't want kilometer, we wanted meter. So kilometer has to go on the bottom so it cancels, and we wanted meter. And for 1 kilometer, there's 1,000 meters. Again, there's multiple ways you could have done this. You could have gone from miles, I think, to feet, then feet to meters. There's multiple ways of doing this. You don't have to do it just like this. Now, again, multiply across the top. Multiply across the bottom. And you'll get an answer. Well, not the answer. So you'll get 88566.83 meters, because our kilometers cancel out. Now that's just our meters. Now we have to look at our hours. So we have 1 hour, and we're trying to get it into seconds. So we don't want hour, we want seconds, hours to go on the bottom. We know that there's 3,600 seconds in 1 hour. Causes our hours to cancel. Multiply across the top. 36 seconds. But our answer we want in meters per second. So we need to divide these two numbers. So you take your 866.83 meters per 3,600 seconds. And when you do that, you get 24.60 meters per second. Now, this is just breaking up into two different things. We're focusing on the miles, then we're focusing on the hours, and then because we want meters per second and per means divide, you divide it out. So you don't have to do it this way. This is just for the ones that don't like the really, really long, drawn-out railroad tracks. You can break it into two looking at the different units. Now, this is not in scientific notation. We need to move the decimal over. So there's 1 number in front of the decimal. Now we're going from a smaller number, not bigger number, bigger number. Bigger number to a smaller number, which is 4.2. So anytime you're going from a bigger to a smaller number, you're going to end up adding, or it's going to become a positive number. So we moved it once, so it's positive. So our answer becomes 2.46 times 10 to the 1 meters per second. And that's our answer. There we go. So the next one I'm going to do is I'm going to do the 202 kilometers per hour. And we're going to go into yards per minute. Now I'm going to do this one with one long, big railroad track instead of breaking it apart. Now, again, you can break it apart. That is perfectly fine. You just focus on the kilometers and then you focus on the hours. But I'm going to do one big one. So we have 102 kilometers per 1 hour. We're going to focus on the kilometers first. There's not a direct correlation from kilometers to yards, but I know that there's 1,000 meters in a kilometer. We don't want kilometers. Kilometers have to go on the bottom. So for 1 kilometer, there's 1,000 meters. And then I look at my chicken duck and I see that there is a meter to yard conversion. So for 1 yard, there's 1.094 yards per 1 meter. Now, you gotta make sure everything cancels. You have a kilometer on top, kilometer on bottom, meter on top, meter on bottom. We want yards. We're good. Now let's look at our hour. We don't want hour, we want minutes. We have an hour on bottom, so therefore we need an hour on top. We know a direct conversion from hour to minute. There's 60 minutes in 1 hour. Our hours cancel, and we want minutes. So then we just multiply across the top, multiply across the bottom, and we get 111,588 yards. Don't forget your units. And 60 minutes. Now we just divide by the top and bottom. And when you divide, you get 1,859.8 yards per minute. But remember, that's not in scientific notation. So we have to move it 1, 2, 3. So the decimal is 1 behind a number. So we moved it 3 times. We're going from a bigger number to a smaller number. So I'll be a plus 3. So in scientific notation, our answer is 1.86 times 10 to the third yards per minute. The next one I'm going to do is the one you kind of had to fill in. So you had to fill in this one. This is the fill-in one. And we gave you 636 grams a centimeter. So 1 centimeter. And we kind of gave you the path that you had to fill in. Inch. We went from inch to feet. And you had to figure out the answer from there. Now, hopefully you got this one, the very last one, the inches. So you know that there's 12 inches in 1 foot. So that one should be a pretty easy one to pull from. Now, you need to look into our chicken duck. Now remember, in our chicken duck, on the conversion chart, there's always 2 different ways. You can do like 1 centimeter equals 0.393 inches. There's also, for like 1 inch, there's 2.204 centimeters. So it can kind of be interchangeable there. And so I think that 2 point is the pounds. There's a 2 point something for centimeters. I don't have that on the top. of my thing. That's what happens when you have too many numbers running through your head. Okay, but for this one, we wanted you to use the 1 centimeter gives you 0.3937 inches. Now this is the one that threw a lot of people off. It did. It threw a lot of people off. And it's because in your chicken duck, there's not a direct conversion from grams and pounds. So, but this is kind of, you had to think. The key thing is how many grams go into a kilogram? Because if you looked in your chicken duck, they had 1 kilogram. It had this. It had 1 kilogram went into 2.204 pounds. It had that in your chicken duck. But we don't have kilograms, we have grams. So you had to think is how many grams go into 1 kilogram. Hopefully you thought about 1,000. So that's why 1,000 goes there and 2.204 goes there. Now, this one is kind of hard, and we didn't even not thinking about it because we're forcing you to choose our path. There's multiple paths you could have taken. Like I said, knowing how many inches, so like for 1 inch, there's 2.54 centimeters. See, too many twos. 2.54 centimeters. So you could have done that path if you're actually making your own path. But we were kind of choosing your path for you. And so, in this case, if everything cancels, we line up, and your answer should have been like 42.74. So that one was just kind of the drag and click. So the one that got a lot of people was this one right here, because they had to convert from grams to kilograms. Now, the last one is about Sally Leadfoot. So, the speed limit is 65, and Sally was caught going 97 kilometers in 102 minutes. And when she got pulled over, and you have to decide, does she deserve a ticket or not? So again, I'm going to do this in 2 parts. So we're going to focus in on the kilometers. So we're at the 97 kilometers. So we don't want kilometers, but we want miles. And there is a direct conversion from kilometers to miles in your chicken duck. We need to make that so long. So now you just multiply across the top, multiply across the bottom. Oh, first we've got to make sure things cancel. Kilometers on top, kilometers on bottom, left with miles. So we have 97 times 0.621, and you're left with 60.24. That's miles. Now, you can't forget about the hours, because we need to go from minutes to hours. Now, it says that in 102 minutes, we need to get that to hours. So we don't want minutes. Minutes go on the bottom. We know there's a direct conversion from minutes to hour. For 1 minute is 60. 1 hour is 60 minutes. So we have a minute on top, minute on bottom, so it cancels. We're left with hours. So we multiply across the top, multiply across the bottom, then divide. You're left with 1.7 hours. Now, remember, we want miles per hour. So what do we need to do with these 2 numbers? Divide. Very good. So we have 60.24 miles and 1.7 hour. So if you divide that, you get 35.44 miles per hour. Now, so she's only going 35. Yeah, it's pretty slow going in at 65, but does she deserve a ticket for speeding? No, she does not. Now, that's in standard form. You have to put into scientific notation. We move the decimal over 1. We're going from a bigger to a smaller, so it'll be a positive 1. So it'd be 3.54 times 10 to the 1 miles per hour. There you go. Hopefully that helped understand your dimensional analysis a little better. If you still need help, please don't be afraid to ask. And have a wonderful day. Bye.